Welcome back. In this video, we're going to start with a discussion about an introduction to multivariable functions by looking at vectors in R2. In lesson 0, we talked about an introduction to multivariable calculus by looking at the forward problem of multivariable differentiation. And in particular, we think about calculus as derivatives and integrals. However, if you're not used to thinking about how you learned calculus, you might not remember all the work that went into your calculus education. For those of you watching at home, I recommend that you copy this diagram into your notebook in your own handwriting. By the time you had seen calculus, which was based on derivatives and integrals, single variable, you had spent something like 6 to 10 years of your mathematical education getting ready for this knowledge. Prior to calculus, you studied something called pre-calculus, which was the study of elementary functions. All of the functions that you saw in pre-calculus were probably single variables, so the domain of those functions had a single input variable, and the output was a single real number. This is what we call the codomain. Prior to your study of pre-calculus, you studied algebra, which is the study of expressions and equations that involve variables. Prior to this, you studied arithmetic. And it's really funny when you think about how this progression worked. Before you were ever allowed to study functions, we needed you to know something about the domains of those functions. How do the inputs that you put in behave? That's called arithmetic. In arithmetic, you study numbers and operations between those numbers. You look at the number line, you look at ordering, you look at how addition, multiplication works, geometric interpretations of the number line, intervals, etc. After you have your head around how numbers relate to each other and how you can operate between numbers, we start to think about a number as a variable. We don't think about all possible values of that variable yet. We just want to say, okay, if you multiply some number by another number and you get some output, what is the value of the input that requires that? It's the starting of analyzing functions, but it's a step-by-step analysis. That's called algebra. So we abstract one way away from arithmetic into algebra, and then we abstract again and say, let's look at the behavior of all types of algebraic expressions that can be grouped together. So maybe you have all types of linear functions, all types of quadratic functions, all types of logarithmic, exponential, polynomial, rational. These groups of algebraic expressions, let's study these in one more abstraction away from the study that we did in algebra, so that we can really talk about how these algebraic functions map inputs to outputs. Then and only then, after you've studied hours and hours and hours of your life thinking about how these things behave, what their graphs look like, what the asymptotes are, what the domain is, what the range is, etc., etc., etc. That's the start of your calculus career. Because the concept of calculus is to construct a relationship between slopes of tangent lines to curves and areas under curves. That's the fundamental theorem of calculus. So when we look at pre-calculus, we really wanted to see how curves behave so that when we start slapping tangent lines on those things, or looking at areas under the curves, or talking about maximums and minimums, we could base all the knowledge that we built on stuff that we understood about those curves. The reason that this model, this kind of hierarchy of knowledge is really important is in multivariable calculus, we need to redo this for functions of multiple variables. In particular, we want to figure out, well, what the heck is a multivariable function? How do those behave? What does it mean to have a multivariable algebraic statement? Well, how do you do arithmetic on multivariables? And this is really interesting. A challenge in this course is we're going to do all of this in less than 5 weeks, whereas previously in your math career, you did all of this in about 10 years. So, when we look at this diagram, the first place to start is at the beginning. In particular, we're going to start thinking about what is the arithmetic on the type of elements we're going to use in our domain of multivariable functions. Well, the first easiest case of a multivariable function is called a two-variable function. And the domain of two-variable functions have two input variables. In other words, it's going to be 2 dimensions. In lesson 1, we're going to talk about the arithmetic, the actual, what are the elements, what are the numbers, so to speak, and how do you do arithmetic operation between things of 2 variables. To get started with this, I'll see you in the next video.